Hi folks, Mr. Dell here. We are looking at proportions and as it relates to tables and graphs and unit rates. So that's our topic for this video. Specifically, I'm going to use a problem this is from CPM, CC2, course 2, and section 4.23. And number 4-50 is the one I'm looking at. So we'll read it together and then we'll come up with a solution. So complete the portion table below and graph the results. So they first want us to complete this table, and then we got to take that table and put it in terms of a graph. So I'm looking at this table, and I would want you to recopy this table onto your own paper and then take that table, and then we can take that table and we'll create the graph together. So I'm going to just go ahead and complete the table as is here. So first of all, I know I've got one set of data. I know that at 6 pounds of nails, it says it costs $2.58, right? So 6 for $2.58. So where can I go from there? Well, if I'm looking, I can see I have a 3 here. And if I know this, it says it's a proportion, right? Knowing it's a proportion, it's going to have a constant rate. And knowing it's a constant rate and it's a proportion that goes through 0, 0, that also tells me I could use the halves, doubles, and those kind of rules. So I can cut this in half, right? 6 divided by 2 is 3. So divide $2.58 by 2. So I would take $2.58, right? So $2.58, and I'm going to divide that by 2. And that should give me, let's see, $1, and so half of 58 cents is 29. So that's going to be $1.29. That's what's going to be in that part of the table. So now let's see, how can I go any further? I've got my 6. I want to figure out my 9. Let's think about where did these numbers come from? If I look at 129 and 258, let's see, 215. If I add, I can see if I add 129, I'm going to add 129 and 215. I can see if I add 129 and 215, I'm going to get, let's see, that's 4, carry the 1, another 4, I get 344. So that being said, if I can see I have 344 here, well, if I knew what this and this were, I can get to this one here. That's what that told me. Let's see. What if I considered what the doubling of this would be? What is 129? Oh, I knew the doubling. We did that. That's 6. Let's see. So if I, I know. How about going from here to here? So if I take 6 to get to 2, from 6 to 2, I want to divide by 3, right? 6 to 2 is divided by 3. So therefore, if I can divide 6 to 2 to get 3, from 6 divided by 3 to get 2, then I can take 258 and divide that by 3, and that'll give me that number. So let's do that one. So let's see, 3 goes into $2.58. How many times? So I'll do my long division here. 3 goes into there. Let's see, 8 times. I'm going to bring my decimal place up and multiply. I get 24. Subtract. Bring down the 8. I get 6 here. So that shows me that at 2, I'm going to have 86 cents. Okay. That's good. So now I have 86. Oops. I meant to put that there. 86, not 8.6, but 86 cents. That's going to go there. So what else can I discover here? Maybe at that point I might want to find my actual unit rate, right? They don't have 1 as one of the things in the table, but if I've got my 2, I might as well get my 1, right? So in my table, I'll just put it over here. I'm going to add to it. I'm going to figure out what my 1 is, my 1 pound, my unit rate. Because if I have 2, then I just divide that in half. So 86 cents divided by 2 is going to give me 43 cents. So that right there is my unit rate. 43. So I have 43 cents as my unit rate. So, all right, that's good because now I can start playing around with my unit rate, knowing that I have a 10. So if I have 1 is 43 cents, 10 would be $4.30 because I multiply by 10. What else could I do? I could figure out what is, if I wanted to, I could look at $8.60 and, oh, well, I could see here the relationship between 430 and 860 is double it. So therefore doubling the 10 makes that a 20. So now I can start seeing some relationships with the numbers. Let's see, what else would I want to determine? If I know it's 43 cents. Oh, I could see. So if I have my unit rate is 43 cents and this one's $2.15, right? Then if I look here, 258, let me write this down, $2.58 minus 43 is going to give me 215, and I needed my 215, so I subtracted 1 from that, so this is going to make that a 5. And over here I already determined that if 129 plus 215 is 344, that means this is 3 and 5, right? This is the 3, this is the 5, so 3 plus 5 is 8. So oof, there we go, got the table filled out. All right. So what's interesting too is they have this X. What goes there? Well, what goes there is what am I doing every time to this number to get these numbers? Well, every time what I'm doing is if I know my unit rate, then that's what I'm using. I'm multiplying 43 cents times X, which is the pounds, and that's what I'm getting every time. So that what goes in that space is 43 cents times X. Okay. All right. Got our table filled out. Now let's do the graph. So what does the graph look like? So I'm going to move my work from here and get a piece of graph paper out. We can see that all these values are positive. So I'm going to go ahead and just create my axes in the positive zone. And I'm going to label this. I'm going to put down here my pounds of nails. And then on this side is going to be my cost. Right? So if I have my units, I can see I want to go that being 0. This is 1. I'm going to go by ones here. 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to go up to 10. I don't think I'm going to graph my 20. I'm going to just graph up to 10. And then I have 43 cents. Then I have 86 cents. Then I have $1.29. So I might go up by, see, I got to get all the way up to at least $4.30. So I'm going to go by 50 cents each, right? So I'll say this is 50 cents on that line. And then this is $1. Then this is $1.50. Then this is $2. This is $2.50. So that would be $3 and $3.50. And this would be $4. And then $4.50. And this would be $5. Do you see where I'm at? All right, so then we graph what we have. So I do have the 1, right? I have my value for 1, so I'm going to go ahead and graph it on my graph. 143, which is right about there. 286, which would be right about there. 129, which is probably right there. And 4, I don't have 4, but 5 I do. 5, 215. Looks like probably right about there. And then 6, I do have 6 at 258, just above 250. You see where I'm getting my points there? 7 I don't have. 8 I do. 8 is at 344, just below 350. And then 9 I don't have, but 10 I do. 10's at 430. So oops, 10 right to there. So here's my points I've graphed. And if you notice these points, I'm going to go ahead and connect them, are actually in a straight line, right? They're linear because it's a proportion. It's a constant rate. So that's my constant rate. And in fact, I know, because I did my equation, I know the equation of this line is y equals 0.43x based on the fact that I got my equation, my actual expression, which represents the cost. Okay, and this always is your x-axis here and your y-axis here. Okay, all right. So there's our graph. So now A wants us to, from now I've got the table, I've got the graph. A says, what is the unit rate? So I'm gonna finish that out on this page here. So what is the unit rate? My unit rate for this, I already figured that out over here, is it's 43 cents, right? For every 1 pound, and I use LB of nails, the abbreviation LB for pound, 1 pound. So that's my unit rate, 43 cents for every 1 pound of nails. And then now it says, what does the unit rate price tell you about the cost of nails? What does the unit rate price tell you about the cost of nails? It tells us exactly that. That's an interesting question because it tells us that I'll just repeat myself, basically 1 pound of nails cost 0.43 or 43 cents. That's what it tells us about the cost of nails. For every pound, in this case 1 pound, so every pound of nails costs an additional 43 cents. All right. There you go.